Hi, welcome to this lesson. In this lesson, we're going to take a look how binary can be used in computer registers for a given application. For example, in robotics, digital instruments, and even counting system. So let's take an example which has been adapted from Zaken Web in a few seconds. But first of all, you need to understand what are registers. Registers, you can take it as small memory unit that can store a group of bits to control a given system. So remember, to store a group of bits. In this case, it can be 1 bit, it can be 2 bit, it can be 3 bits, and so on. Let's jump to this. The device on the left is a mobile trolley with 3 wheels. All 3 wheels can turn left or right, and each wheel has its own electric driving motor. As you can see, these blue items here, they are the wheels, and we're using registers, which you're going to see, to control these wheels. Sensors at the front and rear of the trolley detect an object in the path, which would subsequently stop all movement. So this and this and this, the one shaded red, they control 3 different sensors, which upon detection of an object, they may stop all movement. Now, as you can see, we're using 8-bit registers to control the device. Means that we're going to use a sequence of 8 zeros and 1s. Now, take a look at this diagrammatic representation of the register, which means you have 1, 2, 3, 4, 5, 6, 7, 8. And at any given region here, it can be either a 1 or 0. Therefore, 8 zeros will be helping us to control these 3 wheels and these 3 sensors. So either it can be on or off. For example, the first one here, the first region, they represent the front wheel, which will turn left. When this is a 1 here, it means that the front wheel will turn left. When it is a 0, it means that the front wheel will not turn left. For example, this region here represents for either when the motor is on or off. It means that when this is off, it's going to be switching the device off. And the last bit here, it represents object in the way. It can be a 1 or a 0. When it is a 1, it means that there is an object in the way. When it is 0, it means that the object is not on the way. There is a clear path. Now let's say the bit 10 10 10 10 is represented. Now you can see how they are mapped on the different region. To the first one means that the front wheel will turn left. The second one, it means that the front wheel will not turn right, which is represented here. And the third bit, which is the 1, it means that the rear wheels will turn left. And a 0 here, it means that the rear wheels will turn right, will be off, means the rear wheels will not turn right. Now, you can see that the forward direction is on, means that the device is going to go forward. The backward is 0, it means that it's not going backward. The motor is on, means that the device is on. And then for the last bits, it's a 0, means that it's a clear path. Now, if you see, the 8 bits have been used to control the device, which means that the 1 here is going to turn the wheel left, and the rear wheels is turned left too, and then it's moving forward. And the motor is on, means that the device is moving with forward direction toward the left. So in this way, an 8-bit register is being used to control the previous device discussed. In this case, I'm speaking of this device which is being discussed. So an 8-bit register can be used to control any given device. It can be 9 bits, it can be 10 bits, but each of these bits is used to represent a typical functionality to control that device. For example, to control these wheels here, you can see that this bit has been reserved, this one, this one, this one, and forward and backward direction, we are controlling it using these bits, and the motor on or off is being controlled with this bit. So thanks for watching. This is the use of registers and control systems.